All right, so let's take a look at that application we were using, and we want to get and do this in a more thread-friendly way. Right? We want to do it so we're not tying up the user interface. So that tells us is that this whole do work method, we can't just run this directly as we were because it was running on the UI thread, which is why we saw the problems we saw earlier. So the thing we want to do inside of here, of course, is create a worker thread for that. Right? So first thing I want to do is go up here. I'm just going to declare a thread member variable to the class. Right? When I have that, I'm going to go ahead and just use that down here in my do work. And so what I'll do then is just say, well, take my worker thread. There's a new thread. And what I need to do is pass an implementation of the runnable interface. Right? And I could actually go out here and write another class that implements that interface, or I can actually just kind of create the class in place. Right? So I'll just say new runnable. And it goes ahead and inspects that out for me. So it goes ahead and creates a kind of a class in place there, an embedded class that has the run implementation in place there. So what I want to do now is that any work I want to do on that background thread, I'll do inside of that run function. So all I need to do then here, of course, is take all my code that I was running directly before, cut that out of there, and paste it. So that goes ahead and creates a thread. Now, in order for the work to actually happen, I have to start the thread. And I have that there. So that sets it up for me to go ahead and do the work. Now, one of the things I had to do is that my worker class expected a reference to the context instance, which my activity is a context instance. Now, because I have an embedded class here, right, this is an embedded class, the run implementation, this is referring to that class. I want to refer to the outer class. So what I need to do is just say my activity dot this, so I know which this class I'm referring to. Right, so that way I'm passing my context into that class there. Now that takes care of running things on the background for me, but of course the next issue is I'm trying to interact with the UI, right? And I can't do that safely. So what I need to do, of course, is have some mechanism of performing the updates to that set text so that I can keep updating the UI in a safe way. So what I really need to do is write some method that will do that work for me. So what I'm going to do is write a method here called update display that just takes a string message. All right, so I've got that in place. So now next thing to consider is that if I'm going to be doing these work across threads, I can't be using local variables for anything. Right? Because when that thread runs, the function I'm actually operating on here could be out of scope. So what I really need to do is set a class level variable to store the message I want to set. So I'll go up here and I'll declare that. I'll just create a string member. So I'll use that default text view temp string to store that value. Right? So I'll take that, go back down here, and just assign that message to it. And so now I've stored that string value I want to set there inside of a class level variable. So what I can do now is take the control I want to update, default view, right, call its post method, which will actually go ahead and run this code on the appropriate thread. So I need an implementation of runnable to do that. So I've got that there, and I just want to do whatever work I want to do. All I want to do inside here is just set the text of that control. And I'll use my default view temp. So that way all that operation actually happens on the correct thread. So what I basically end up doing here is instead of setting the text directly as I was before, I'm going to call this update display each time instead. Okay, and with that now, I can run that operation on the background thread, so I'm not tying up the user interface. I can safely update the user interface at each step along the way, because each time I get something done, I go ahead and call out to this update display, store that string message in a class level variable so it's accessible from all the different threads, and then basically say that I want to go ahead and do that work. Whenever the UI thread runs this code for me, it goes ahead and does the update for me. Okay, so with that, I should be able to do a build, make sure everything builds correctly. Okay, and I'll go ahead and run this, and we should be able to see then the user interface updating as these operations go on, but the user interface should still remain responsive. Okay, I've got it there. I'm just going to say menu, do work. And you'll notice as it goes on, it says starting, retrieve location, retrieved address, and then done. Right? So our UI stayed active, yet we were able to do all that work on the background thread for us. So we got the work done, we updated UI, all that worked well for us. The other thing that's really kind of interesting to consider there, as I go back to the code, is that we end up doing a lot of extra work to make that happen, right? In order to kind of get everything done, I end up having to write this extra function, do this extra post out here. Another thing to consider too that is that if I was doing something more complicated, where I wasn't just stepping through do this, then do this, then do this, you might even run into some race conditions, right? Where one bit of code calls in, says update display, sets the message. Another bit of code calls in, says set the message to something else before the first message ever got set. Right, so this is helpful. It lets us run some things in the background, but there's still a lot of complexities to it. So we'd like to find something a little better than this to help address the problem.